All right, welcome into Linux Priv. So we're just going to kind of go through. We're going to look at some Priv on Linux. There's a bunch of different ways to privilege escalate. We're just going to look at a few of those different ways. The best way to learn Linux privilege escalation, just like the best way to learn web app, is just to get out there, do some CTFs, and try to see if you can get somewhere within those CTFs. That really is the best way. And if you're stuck, reading a walkthrough for the CTF. Right, those are really the best ways. That's how you're going to see the most information at once. Be able to see, how to do path exploitation, Python exploitation, just a whole bunch of different things that are out there for Linux Priv. I'm just looking at the stuff that I've actually seen in real life on organizations' machines, and mostly that, like I said before, that low-hanging fruit, like we've looked at before. So very first thing we have to do is we have our Linux Priv machines already started up, and I've created a Linux Priv directory, right? And now we need to find the machine. Like, where is this machine? So port 22 is open on it. So we can go ahead and do an mmap tac ptac. We'll say tac vv, and we'll do a 192.168.0.0/24. Okay, and then from here we're going to do is just say tac open. We really want to see which ones are open, and then we'll go ahead and we will t that tac a into mmap.text. And let's see if we find anything on here. Oh, I did tac ptac. Excuse me. I just want to look for port 22. I'm sitting here like, man, there's a lot of stuff coming back. Must have a couple labs running. There we go. So, okay, cool. We see two of them, right? So two different things are open. So we have this one that's in VMware, another one that's unknown. So most likely the one that's VMware is probably going to be the one that we want to look at, which is going to be this 192.168.0.118. So let's go ahead and we'll grab that and let's mmap the whole thing. And we'll do a note, don't ping that. We'll do a tac sc, tac sv, and we'll do a t tac a, and we'll just say port scan or something like that, .text or whatever else, right? Full port scan, something like that, right? So it looks like we have quite a few ports open in here. Some things that stand out to me are SSH is open, port 22, and also port 2049, which is a mount, right? That's how you can mount things, and a bunch of these other ones just go along with mount here, but that one right there is something that we might be able to look into. So we see that port 22 is up and that mount. Let's go ahead and we can SSH into port 22. And that's going to be with the username of priv1 and password priv1, and that is in your walkthrough there. We'll say 192.168.0.118, I believe it was. And we're just going to say priv1 at that, right? Priv1 at that. Okay, and we'll say priv1. We should be able to get in. We can, okay. Let's go ahead and get a bin bash. Get a nicer shell here. Awesome. All right, so there's priv1, right? The very first thing that I always like to do is I always like check bash history. Okay, so we can go ahead, we can cat.bash history. There's a couple things I always check first. Is bash history able to be looked at, right? And it is, okay. Looks like he's not really doing much on here though within that bash history, but that is something I always like to check, like right there. Another thing I always like to check is if we have sudo capabilities. We do the sudo tac-l. And we do. Okay, we actually have all sudo capabilities. Okay, so we could just technically just do a sudo su if we want to, right? And we say priv1, and we're now root. Let's go and exit out of there. Let's see what some of these other sudo capabilities are. Okay, we have this user bin vim, user bin less, looks like just fine, and then temp cleanup.sh. This temp cleanup one, that would really stand out to me. All these would actually stand out to me, but this one really stands out to me. And the reason that this one does is because whenever something's restarted, temp should be gone. So let's go and cd in that temp folder. We'll do an ls tac-la. All right. And we can run that with sudo capabilities, right? So what we should tend to be able to do is actually run that with sudo with no password. We'll be running it as root with no password. And we should be able to make whatever we want in here. So we could do something along the lines of maybe even just a bin bash. We'll just try that. Echo bin bash. Into cleanup.sh. And then we can go ahead and we can just say, hey, sudo /temp cleanup.sh, see if that works. Okay, may have to make that executable, changeable plus X for cleanup.sh. And we'll go ahead and we'll run sudo temp cleanup.sh. And we are now root. All right, there's plenty more things that we could do. We could create a callback to ourselves. We could change one of the SUID bits that we know are vulnerable. We could have that echo maybe into a cron job or something like that. We could do a lot of different things, right, with that, but we'll leave it as that for now. You could play around with that one and see what else you can do with it. We also have this user bin vim and user bin less. Let's go ahead and check out those two and find. So let's go ahead and let's open up the web here, and we'll go out to GTFO bins. GTFO bins. And we can see that this site, like right here, gives us a whole bunch of different ways to priv-esc. So we could try to type in, I don't know, less. All right, less with sudo capabilities. We can, let's see here. We can type in sudo less etc profile bin sh. So let's go ahead and give that a try, like right there. Okay. Colon Q. Let's try quit out of there. All right, let's go ahead and do a, oh, you want to know why? Because in here we have to actually do that bin sh. So let's do a colon Q. All right, and we'll do this one like right here, and then we're just going to do this bin sh inside of there, and then that'll give us our shell. So let's go ahead and enter there. Hit A to be able to type. Control Shift V. All right, escape character. Q. That's always a pain whenever, okay, there's that. Enter. There we go. ID, and we are root, right? So let's go ahead and exit out of there. We'll go ahead and we'll that Q out of there, and we'll be back to priv1. Okay, cool. So now let's go ahead and let's continue on with our okay, so now what we can look at is let's go ahead and look at that Vim one, right? So we also had Vim in here, so let's press back. We'll see what we can do with Vim with sudo. Actually, you know what? You guys go ahead. You guys do Vim with sudo. I don't want to take everything away from you all. Just do all of it, right? So let's go ahead and let's try to look at, see if there's any SUID bits. So we'll do a cat scripts SUID bits. I should be able to, oh, because I'm not. There we go. Let me get into my actual Kali machine here. Cat scripts SUID lookup. Okay, what we could do is we could actually grab any one of these. We can throw this up here. We can see, do we have any weird SUID bits? Now, something with SUID bits is you just kind of learn these as time goes on. All right, you learn what's weird. Okay, make like right there. Don't know if that one is something that we should be able to do. Head, I definitely know we shouldn't be able to do. So since we have those different SUID bits, we can go ahead and look them up over here. We say, hey, make. Is that one? And it is. So we have an SUID bit like right here for make. And it looks like we are able to run some type of command with it, right? So we have command bin sh tag p. So what it looks like to me is if we break down this command that we're putting in like right here, we're saying, hey, command is going to equal / bin sh, right? So we're going to make a shell, okay? And then from here, we're going to call for that command utilizing make. Since we have an SUID bit, oh, it didn't like that at all, okay? Oh, you know what? Make might not even be installed on here. That may be why. Or it may be because we're doing /make. We don't want to do that. We want to actually type in our full path that we saw up here, which is should be user bin make, correct? Yep, user bin make, okay? So that's actually the command that we actually want to type in. So we'll give it that command like right there, hey, bin sh tag p, and then we're going to call for that command. That's what that $ command is. Doesn't really like to see, yeah, that's not anything. Let's try and make. And then there we go. Are we root? We are not. We are just still just that. So it looks like that one did not quite work for us, like right there. And that's okay. Let's go ahead and let's try it with bin bash. Right. Let's try that again. All right. Didn't seem to care about that either. Let's go ahead and cat or ls, because I have all seen things like this before too. ls tech la / bin bash. Okay, I was just seeing if all of a sudden we put an SUID bit on there, but it doesn't look like this is as vulnerable as what it first let out to be, right? So it looks like we're not really seeing much with it. So if it creates a local SUID copy of the binary, runs to maintain elevated elevated privileges, but this like right here it's not working on, and that's all right. There may be other ways to be able to do it. There may be other things we could try, but let's go ahead and try that head one that we had. Okay, we'll say head SUID bit, and here's the SUID, and we can actually read a file with this one. So what we're going to do with this one like right here is we're going to give it an L file, right? It says, hey, L file, like right there, right? So let's go ahead and say L file equals etc shadow, because we shouldn't be able to read that. Let me try cat etc shadow. Okay, I cannot read it, right? So we'll throw that into there. We'll say L file equals etc shadow, and we're going to try to run this as root. And then we'll just say /user bin. And there we go. We have now read etc shadow within this box like right here. So now that we can read that, we could see that there's a cyber ranges user. We could try to brute force them or whatever else, or see, if we can find their password or whatever else, right? Other things that you may be able to do are things like cron jobs. Okay, cron jobs are scheduled tasks, all right? So we can utilize something called pspy. We can grab that out of GitHub. So we'll go over to GitHub. Or excuse me, actually, let's go to Google. Then we'll type in pspy. There we go, Google. Okay, then we'll type in pspy64. And we can get that on GitHub. There we go, pspy. All right, for this one, like right here, we can just go to releases. And we want pspy64. Now remember, it's whatever system you're loading it onto. So if this was a 32-bit system we're loading onto, we would say 32, right? So we just download that. Awesome. So now if I go ahead and I can move from downloads, pspy to right here. Now how do we get that file to here? There's a lot of different ways we could do that. And this is kind of going off of what was written inside your PDF, but let's go ahead and let's look at how to get that file from here to here. Okay, one thing we can do, we create a web server, right? We can grab my IP address, and we can go ahead and we can say, hey, I want to do a wget on HTTP. That, remember, I am already on port 80, so I don't have to worry about a port back here. We say pspy 64. All right, awesome. LS-LA, there it is. All right, so I've got pspy, right? Let's go remove that. Something else we could do is we could try to SCP it over. I know the password for this user. This is my Kali machine, right? I know the password for him. So I could do a sudo SSH or sudo systemctl SSH enable. And then, sudo systemctl enable SSH. Service is where we put the program in first. All right, so we have that. And then we could use SCP. Now, SCP runs over port 22. This is one of those questions I think in Net Plus or whatever that try to confuse you. It's like, match the ports with what it does, or match the port numbers. 22 goes to SCP. Kali at, and we're going to say 192.168.0.10, I believe it was. Is that my IP address? .0.10. If you're a good hacker, you never know your own IP. /home, Kali, and then we just have to call for like wherever it's going to, right? /privesc. /pspy64. All right, and I want to drop that right here. Okay, I actually don't know if I need the period on this one, but we'll go ahead and we'll hit enter. All right, it's saying that the port is actually closed, so let's go ahead and head back over to here, and we'll say start SSH. We'll try that again. Yes, we can go ahead and grab that fingerprint, Kali, and then there we go, okay? We now have pspy64 over here again. We can also just copy and paste the file. We can try to do that. So we can go ahead and cat that pspy64. We'll see what it looks like. We're not copy and pasting that now, are we? All right. We could also use netcat to transfer things. We could base64 the file and transfer it over. We could utilize that mount that we saw, the NFS mount that we saw, right? And transfer that file over. So let's go ahead and look at that real quick. Let's do that show mount tac e on this IP address up here, and it's home cyber ranges. So we may not be able to do it with that just because it's going to cyber ranges, and we most likely cannot get into home cyber ranges, can we? Nope, we are denied from doing that. Okay, so but we could SCP it over, we just wouldn't be able to run it, right? But there's a lot of different ways, or we could use the mount over there, we just can't run it, right? But there's a lot of different ways we could end up getting a file onto a system. Okay, a lot of these ways, I mean, SCP, that also works if you're utilizing PowerShell. You could PowerShell something from your Kali machine over into PowerShell on Windows, right? We could wget using PowerShell. We could curl, right? We could use curl because some systems don't have wget. So we can curl HTTP 192.168.0.10 slash PSPY64. And then we just need to make the out file. I think it's just a little o. Don't remember if it's little or big O. We'll try little o, PSPY64. All right. Oh, curl's not even installed here. So wget was actually the better one to actually use. All right. So, but a lot of Windows machines, curl's already installed on. So you do that tac o. I don't remember if it's a big or little o for saving, but if it doesn't work one way, do it the other way. So that now that we have PSPY64 over here, let's go ahead and check that out. Let's go ahead and we'll do a change mode plus X, PSPY64, and then we'll go ahead and we'll run that. Now, what PSPY64 does, it looks at cron jobs. Cron jobs are scheduled tasks. It's not really looking at the scheduled tasks per se. Like if someone were to get on here and start running commands, you would see them getting on here running commands. Okay. But what this does is it shows us what commands are run. And amazingly enough, there's something called binsh taxi opt ping.sh within the opt folder. A lot of companies, organizations, and CTFs, all those, they utilize the opt folder to drop things in there that everyone is able to use. So if you see some weird things in an opt folder, well, they may be running it, right? They may be running that every minute. They may be running that once a day, whatever else. But if we can mess with this file and root is running it, we may be able to do something. Let's go ahead and try it. Let's go ahead and cd opt. Let's see if we can mess with that file. It says we can. It says we can write to it, right? We can read, we can write, we can execute. Let's go and cat that ping.sh. And it looks like it's actually just pinging itself 4 times, okay? Now, one thing we want to do, especially if we can write to it, is we always want to either A, copy what's already in here and re-put it back, right? We don't want to change up a file system and then leave it like that. We have to put it back to how we originally found it. Or we can just go ahead and we can move ping.sh to ping.sh.back, right? Now, oh, we're not allowed to do that though. Okay, what about copy ping.sh to ping.sh back? Can we do that? Okay, we can't do that either. So what we would have to do is we'd have to grab this information like right here. And we would have to say, hey, I want to echo this into ping.sh. And then what I usually like to do is actually say what it belongs to, right? So I'll say like ping.sh, and I'll say something like 192.168.0.118 opt folder, right? So now I know that's the command, or that's the file name. That's who I pulled it off of. This is where it was, right? So now I know every single thing about it. So when after a week, 2 weeks, a month of working on something, I might not remember where ping.sh came from, right? When I have print screens, things like that, yes. But I don't want to look through 100 pictures just to figure out where to put this at. If I could just name it, take that 5 more seconds and name it properly to be able to put it back in that proper place. So let's go ahead and nano that ping.sh. All right, and it's saying that's actually not writable. So we may not actually be able to do this. It says that we can read and write to it, but it's not allowing us to. I wonder if we can remove it. We cannot. I wonder if we can, let's still try just to, nope, directory is not writable. So it's saying, hey, yeah, we might be able to do stuff with that file. We can't write to this directory. So we can go ahead, we can see what the ls attack LA looks like right here. And yeah, we can only read stuff in there. Root owns that directory. So we're not able to change things in there. But we may be able to get to a user that can, or, we can try to figure out something, right? We've already figured out how to get to root. But that is another thing that we might be able to do is mess with that file like right there. We also saw that mount, and that mount is going to home cyber ranges. Now, something with mounts, right, is we can just kind of get into it. So we can mount it to ourselves. Let's go ahead and make a directory called mount, and we'll do a quick mount tac t. We have to do a sudo mount, tac t, nfs. All right, that's what type of file it is. Okay, these shares like right here, they're nfs 192.168.0.118, and we're going to mount home cyber ranges, right? And we're going to mount that to the mount folder that we just created. Right, we'll hit enter. Now, if we go ahead and we cd in that mount folder, we can see that we have now mounted his home directory into here. Well, if we mount his home directory, then couldn't we add stuff into it? Maybe like if we do a make directory.sh, and then we cd in that .sh, right? And then we go ahead and we look at our own stuff. So we can cat scripts.sh or cat that.sh ID public, our public key. And couldn't we end up throwing this into our authorized host? Echo that. I believe it's actually into authorized keys. Right? Couldn't we throw that into there? And then from here, SSH tac I, IDRSA, cyber ranges at 192.168.0.118. Can we try that? We can. And look at that. We are now cyber ranges on the system. All because we can mount something to his directory. Right? So we just mounted our own key in there. That's all we did. And now we can now log in utilizing, we don't know his password. We don't know anything. We're utilizing our key within his directory, made him an SSH directory, and then utilized our key to get in there. Right? So let's go ahead and let's do an ls-la. So now we can do whatever we want here, right? We can do whatever we want. CD in desktop. All right. Cool. Sudo tac L. We can try that. We don't know his password. That's all right. Let's go ahead and let's see if he can mess with mount. Let's go and CD in opt or mess with opt. ls-la. Let's see if he can move ping.sh to ping.sh.back. Let's see if he can do that. He's also not able to. All right. So that's not something that we're able to, like right there. But if you wanted to mess with this, if you wanted to see it actually work, if you wanted to actually write to it, what we could do is we could utilize one of those scripts that we used before, right? Become root. So we'll go ahead and we'll do that like real quick. Because obviously this was an overview on my part, like right here, because I wanted you guys to be able to do this. But we can just do a sudo su, right? Priv1. Okay. And what we can do from here is we can actually go ahead and change that opt folder. So we'll just go ahead and we'll say change mode 777 for /opt. Okay. Now if I do an ls-la again, we can see that we can read, write, and everything else to it. All right. And now I can go ahead and cd into that /opt folder, move that ping.sh to ping.sh.back. All right. And then we can go ahead and we can nano ping.sh. And we can just say something like, we can make a callback to ourselves, right? So let's go ahead and cat scripts bash reverse shell. We can go ahead and put a bash reverse shell into there. We'll say that/bin bash 192.168.0.10. We can leave that port as 9999. That's whatever. 0.10, 999. All right, awesome. And then we can go ahead and we can run that pspy again. Let's get our listener up and running. And the reason I like to run pspy again is just to see that once it does actually run, is it actually running, right? We can go ahead and change mode that to ping.sh plus X just to make sure it is executable. And then I always just like to go back to the temp. Let's go ahead and pspy 64 just so I can see like, hey, if root does run this, do I actually get a callback? Or did I mess up somewhere? Or is there something I need to change? Or do they not have this dev TCP thing? Or do I have to use a netcat reverse shell? Or a Perl reverse shell? Or anything else other than a bash reverse shell? You know, what else can I possibly use? Is it actually executable, right? Can we actually execute something? As you just saw, you see what happened there. Like I said, it's just showing you what commands are running. But can we actually execute it? You know, things like that. Is root actually executing it? You know, just all those different things. And I just like to have pspy up and running just to see like, hey, when is this executed? If it is at all, it may never be executed again. We have no idea. It may be executed every minute. We have no clue, but we do get a callback. So we do see that, hey, you know what? We got that out ping.sh. We got ourselves a callback, right? And so now we are root again. So now we're root. We can go ahead and cat etc shadow or whatever else, and we have everything that we would need inside there. I think that's everything on this portion of it, right? But what we're also going to look at, we're going to look at one more thing, and that's going to go ahead and that's going to be limpies. So limpies, what we'll do is we can go ahead, we can exit out of all these things, okay? We're actually going to exit out this guy. Now, any user can run limpies, and what limpies does is it looks for problems within a system to be able to see, can you increase your privileges? And it also looks at the the uname tag A and sees like, hey, is this vulnerable to a kernel exploit? Is it vulnerable to, just anything like that? So let's go over into limps here. We should have what is it under images? Where's this thing at? That's actual images. Okay. What's under builder here? Let's say we should just have, oh man, limps is going a little bit hardcore here, huh? Let's go back to limps or actually just p's and g. All right, because we should be able to go down to releases and see limps. Now there is also a win ps. Okay, that's something else, but we're not going to look at that yet. We'll just grab this limps Linux ARM64-bit, like right there, or we actually just grab this limps.sh. I've never had a problem with this one. Never seen it give. It's never given me any problems right at that. So let's go ahead and move from downloads limps over into here, and you can go ahead and you can get this to this machine any way you want. I'm gonna go ahead and I'm gonna SCP it over. limps.sh. Oh, because I didn't put a period at the end. There we go. Okay, and then I can just go ahead and I can type in bash limps. And if it's not in color, it does actually say how to put it into color. There's like a little error thing up here on how to put it into color. I've never had it not in color on Linux. On Windows, usually you have that problem. And it'll give you a little thing on Windows. It's like, hey, to have this in color, do this, right? So I've also never used limps on actual live network. I've only ever used them in CTFs. Usually, like I was saying, the things that we just saw there, that's usually what I see in actual live networks. All right, so we can go kind of down through here. We can see what their little codes are up here, such as in like red just means like, hey, this is bad, right? Red you should take a look at. Red and yellow is a 95% privilege escalation vector. Light cyan is users with console. Blue, users without console, amount devs. Green, common things. And then light magenta is your username. So anything that your username is running, right? So we can go ahead and we can scroll down. And if your kernel was exploitable or some of that, it would show in there like, hey, this kernel is exploitable, or if sudo was exploitable or something like that, it would definitely be red and yellow. Now, just because limps says it's exploitable doesn't mean that it is. So don't just think, oh, well, it says it's exploitable and the exploit isn't working, so the box is broken. They may have, changed out something. They may have made it so it looks like it's exploitable, but it's actually not. Right? So let's keep going down. And we should actually see in our SUID information, we should see some red and yellow here. Notice it gives us all the internal ports that are up and running. All right, we can do that with an SS TAC TULPN. We can see all those different ports that are up and running, those internal ports, because if they have a port 80 web server and then a port 8080 on the internal, that might be something you might want to look at. Right? You might want to look at those internal ports and be like, huh, that's weird. Why they have a web server externally and internally on the same device. All right, there's our known host like right there. Okay. Oh, that's for Priv 1, excuse me. And there we go. As you can see, hey, it's saying that, hey, make is vulnerable, but we didn't get that one to work. I'm sure that with a little bit of more time, we can get to work. Head is also vulnerable, it's saying, right? If you are root, it will just be like, hey, you're already root. It'll still go through this whole thing, but you're going to see a lot of stuff in here. So like, yeah, you have access to everything. Congratulations, you're already root. But kind of like, I don't know why you're running me. But as you can see, there's a lot of things in here. And sometimes, especially during CTF stuff like that, you just have to start reading this stuff. And really, like I said before, and I've said it a bunch of times now, just doing boxes and just doing those different CTFs and just practicing, that's what's going to allow you to be able to run through this and start to look at things that you know might be vulnerable or things that look weird to you or just things like that, right? That's like right where you would start to look at all this different information and see like, hey, what can I actually do here? And you might, when you get into it enough and you start getting a rhythm going of how you check things, you're probably not going to use limps that much anymore. Limps is kind of like a Hail Mary at the end, especially because of how loud it is and everything else. Everyone's going to know that you're in that system, right? So hopefully you all learned something. I know this was a little bit longer one. I had a lot of fun with it. We got to do some Linux Priv. There's a lot more things out there that you can utilize, a lot more tools and things like that that can be utilized for Linux Priv. I highly suggest you get out there, try some different Priv, try some different ways to be able to do things, put some things on this machine, maybe, right? Put some file path vulnerabilities, things like that, and go ahead and try to exploit those. All right, I'll talk to you all later.